I'm joining online basically, and I, I let me tell you that we are very, very privileged to have you with us, and it's very kind of you to agree for giving this seminar to our faculty and students. Uh, uh, the purpose of such webinar is actually we understand that, yeah, you're able to hear me. Yeah. So, madam, the purpose of such webinar is twofold actually. Not only that we get benefited by your lectures, our new faculty members also understand what makes them successful in getting some funds. That means how do I prepare a good proposal? What funding agencies look for in a good proposal? And also the second purpose is that people like you who are very experienced and have been dealing with the research funding for a very long time actually make them aware of different schemes which are available for them. So with this intention we started, and I again repeat that it's very kind of you that you agreed to interact with our faculty and students. And for my colleagues, it's pleasure for us to have Dr. Anita Aggarwal with us. She is scientist F in DST, wherein she looks after the technology development transfer portfolio and also the medical devices. Okay. And I wanted to apprise you, Dr. Aggarwal, that IIT has a center of biomedical engineering, wherein we work with lots of focus on medical devices. And it's pleasure for us to listen to you. I pass it on to Dr. Amlesh to take on from here.
Thank you, sir. Thank you. Thank you.
Yeah.
So, Dr. Aggarwal, you may start now your presentation.
Sure, sir. Thank you, Professor Khare and Dr. Mukhopadhyay, who was my senior colleague from the department. So I look after technology development programs in DST. So in DST, we have majorly three umbrella schemes in which we look at innovation and technology development. One of the scheme component, the third umbrella scheme, is where we look at the innovation and technology development component. So, I will be talking majorly about the technology development programs which are handled by my division today. And I will be giving stress on how this innovation capacity and capability which have been built through technology development programs, how it has helped the country to utilize this knowledge translated into economic benefits. So, like if you look at currently all the missions of Government of India, Make in India, Swachh Bharat, Smart City, Incredible India, Startup India, anywhere you all around you see of any mission of Government of India, technology plays a key role in implementation of these missions, whether it is Digital India or whether combating the pandemic also. Technology has plays a very important role in the whole scenario of the country. And if you look at, apart from mapping our schemes to the mission of Government of India, we have to also map ourselves, our programs to the Sustainable Development Goals. So keeping this in mind, so we have redesigned the schemes of the department, which caters to the need of a vast stakeholder society. So if you look at the emerging space of science, technology, and innovation in the current global scenario, in this new global economy, so innovation, technology, and science are three important pillars of the society, which play a key role in national prosperity. Science, like wherever you look at, even a developed nation also, science, whosoever is doing science or basic R&D, most of it is scholarship driven. It is funded by the federal agencies or the government bodies. So when this science is converted into a technology. What is technology? This is gainful and useful knowledge which emerges out of the science that you have done yesterday. So once it is converted into a technology, then it is market driven, and you can expect some investments from the side of market. And when you gain the leadership in that usable knowledge, then it becomes an innovation. And innovation is always competition driven. So all these things, when linked together, they create job and they create a value in the system. So a technology has no meaning if it is not creating any value to the system. Maybe it is solving a social problem or getting economic benefit. So if you look at the new education policy also, so a lot of focus has been laid on the research, the quality as well as the quantity of research. And the policy also talks about the significant expansion in research capabilities and output across the disciplines. And they also talk about how do you network these various disciplines, bring them under the same umbrella, and then integrate them, network them to come out with a problem-solving approach. NSF and NRF has been really talked about, and in this budget speech also, FM announced the budget allocation for the NRF. And over the years, if you see the trend since last 3-4 years, in every year in budget speech, one or the other mission for science and technology has been announced compared to the past phenomena. So this itself indicates that the government has recognized the rightful place of science and technology in the country and how its contribution towards the economic development. In the Economic Survey of India, a whole chapter on science and technology was featured 3 years back. So all these trend indicators really indicate that we are moving towards a society which will be like knowledge-based, and knowledge will be converted into technology and innovation for gainful use of society. So education, our new National Education Policy 2020 rightly points out the students and the faculty, they should be equipped at the very young age with the right competencies, right capabilities, so that the seeds of innovation can be seeded at the young age. So if you look at the science and technology policy, which is like governing our country, so first science and policy resolution was articulated in 1958. That was the era when we had just got our independence, and at that time the stress was more on laying foundation for science and scientific temper. So after that we progressed to technology policy statement in 1983, and the focus during that period was technological self-reliance, because we were in the era of technology, of denial of technology. So during that, again, at that time also we were talking of technological self-reliance, and today again, when we are talking of Atmanirbhar Bharat,
Anita, one
Yes,
minute
sir.
to interrupt you.
Yeah.
Are you moving with the slides or you are just giving the intro?
No, I'm moving with the slides. Slides are not visible.
But your slides are not moving.
So okay, so this is not. On my screen, I have moved on to 4th slide.
Yeah.
So I will share it again, sir.
Please go to full screen mode and reshare it maybe.
Okay, I am on full screen mode only. I will reshare it. Is it visible now? Just one sec.
Not yet.
Is it okay?
Yeah, now it is.
Now it is okay. Okay.
No, we'll just go to previous slide just to,
Yes.
is it visible? Yeah,
Yes.
this is visible to education policy.
Yeah, it is now moving. Yes. Okay.
Okay. So now I'm talking about science and technology policy. How like the science and technology has progressed in the country after the independence. So in 1983, when we were denied the important technologies, so that at that time the focus was on technological self-reliance, and Department of Space and Atomic Energy. They gained really good funding and momentum during this period. The foundation stone for these departments for their way ahead was established during this period. Then the first full-fledged science and technology policy was launched in year 2003, where the ambition for science was set. So after that period only, there was a gross increase in expenditure on R&D. And you will be happy to know that since last 4-5 years, the expenditure of DST or the budget of DST has really doubled. And if taking inflation into account, this increase may not be that substantial because even researchers have also increased manyfold during this period. So, but at the same time, we see private investments in terms of industries coming to the country and MNCs establishing their R&D centers has also gone up substantially. And eminent institutions like IITs and NITs, they have also got a considerable share in funding by these MNCs, as they have created some of their centers, and they are also working in close collaboration with these institutes of eminence. So coming to the next science, after 10 years, then the aspiration for nation was set by STIP 2030. So here science, technology, and the third pillar of innovation was added to the policy. And the aspiration was set to have a science research and innovation system for high technology-led pathway for India. So this aspiration was set, and gender inclusion and how to reach this goal, the ways and pathways and the implementation plan was also worked out. So right now, post-COVID, we are talking of new science, technology, innovation policy. So which will be like with the changing ecosystem, when this new education policy was launched and health policy was also launched, new intellectual property policy was launched. So with integrating all these policies into our ongoing programs, so this new education policy is being framed and which is open for consultation now. So here again, technology and innovations are taking the center stage now. So over a period of time, the aspirations of the people or society by and large has changed from doing science to technology to the solutions, the problem solving approach. So right now the focus is more on using these tools to which are the like pillars of science and technology, so physics, chemistry. These disciplines are all being used as a tool to have a problem solving approach and arrive at a solution to a particular problem. So if you look at now, so we are looking at science, technology and innovation for sustainable development for the country. Just to confine to all the missions and sustainable development goals. So the vision components of our department, they include enhancing the quality and relevance of R&D, translation, technology translation and innovation, and how to take it to market, connecting academia, R&D labs, industry, Institute of Higher Education, ministries, how to integrate them, how do we bring them all together on the same platform and come out with the solutions using S&T inputs. And then societal connect and contact. So this is another important aspect. How do we take the fruits of science to the common people? How do we take this science to people, and how do we have people for science? So diversity and inclusion, which includes geographical inclusion, inclusion of gender, inclusion of like all stratas of society. So how do we have inclusion so that the benefits of science can be transferred to all the levels? And then next is very important, how to align all our the work of S&T to the national priorities. So with this vision focus, so our technology development programs have also evolved over a period of time. So right now the DST is operating under 3 main umbrella schemes where we have S&T, institutional and human capacity building. And I think Professor Mukhopadhyay is the best person to talk about this. So we have our infrastructure and all scholarship streams under this umbrella. And then we have R&D schemes and innovation, technology development and deployment, under which we are implementing these technology development programs. And the other key players in this umbrella are the National Entrepreneurship Development Board. So they are supporting the technology business incubators and all entrepreneurial activities through the Nidhi umbrella. And then we have AGIG institutions, which are funded by DST, and these are two service departments, SOI and NECO. So primarily today I will be talking about the technology development programs, which fall under the umbrella of innovation and technology development and deployment. So if you look at support chain, which is available in DST for technology development, so we have different schemes which are relevant to different stakeholders, and they are able to, each scheme has a different specific deliverable, and they are able to, if you integrate, if you connect all these schemes, so we can provide an end-to-end solution for technology development, starting from the proof of concept and to the end, taking it to the market. So if you look at Science and Engineering Research Board, the Autonomous Institute of DST, Autonomous Organization of DST, so they support basic research. And with that basic research, you can have support to establish the proof of concept. You can do the science, you can have the proof of concept, which tomorrow you want to convert it into technology. So next, if you look at international division, it provides a very good platform to do international collaborative R&D with countries that have technical strength. So you can, keep on looking at their schemes. They are launching joint calls with different countries. Apart from that, in some calls, they have identified the theme areas also. So DBT is also launching international programs, bilateral programs, multilateral programs, as well as DST is also doing it. So next comes the technology development programs. Once you have established the proof of concept, and now you want to work on laboratory prototype, and you up to demonstration, you can garner support from technology development programs. So we are in the window where you have a laboratory prototype with you. It could be an open blackboard model or some kind of proof of concept. Whatever idea you have in your mind, it is workable. So that proof of concept should be done in your lab itself. So once you have that, you want to convert into a laboratory prototype and later advanced prototype also, which can be taken for limited validation and testing. So technology development programs is platform for your needs. Then we have NSTDB division, which is supporting entrepreneurship through technology business incubators. So their stakeholders are like students as well as faculty. For us, our stakeholders are only faculty members. So under technology development programs, we encourage participation of industry. I'll come to it little later. Then we have Technology Development Board. So Technology Development Board, they provide us financial assistance to industries. So their stakeholder is industry here. So I have covered faculty, I have covered the students, and any Indian citizen who want to develop the technology, do the technology development through incubator entrepreneurship. And the next is industries, the industries who are already in the system. So if they want to commercialize technology, this could be technology which they have brought from abroad and they want to adapt it for Indian applications, or it could be any technology which they have acquired from the institute or they have developed in-house and they want to commercialize it. So Technology Development Board comes when anybody is interested in commercialization of technology. So that will be beyond technology level 8, where you have done everything and you want to set up a commercialization or manufacturing line. So we have Technology Development Board there to provide financial support. Then we have institutes like Shri Chitra Tirunal Institute of Medical Sciences. So they have Center of Excellence for supporting product development and validation, especially related to biomedical devices. So they have animal facilities if you want to do any kind of trials, and they have this platform also where they support the validation studies and then they guide you also how to take it through different clearances. Then we have Patent Facilitation Cell, which is working from IIT premises only. So they help in filing the patents for the technologies or for the research done through support of DST. Then we have TIFAC, Technology Information Forecasting and Assessment Council. So they work on preparing status reports for different technologies, and they have also launched Technology Vision 2035. So these are some important documents which say what kind of futuristic technologies we will be needing as we all grow ahead. Then we are also working in collaboration with some ministries. Like we have this Society of Biomedical Technology, SBMT, so which is a DSK DRDO initiative, and Ministry of Health is also a partner in this initiative. So here we are looking at the technologies which are spin-offs of like defense technologies, and they can be used in the medical applications. So you will be glad to know the first cochlear implant in India, developed through the efforts of SBMT, is undergoing clinical trials now. So they are looking at development of affordable technologies for common man. So they use defense DRDO, they use their own spin-offs also. And plus through this, we are giving support to some institutions also where any further adaptation or modification of these technologies is required. So this is another platform which we have created for development of biomedical technologies. So coming to the technology development programs of DST, so our main mandate is to convert proof of concept for technologies, techniques, processes, and products into advanced prototypes, which can be used for validation and demonstration in actual field settings. So as the end point or end deliverable of any project which is funded under technology development programs, so we are looking at a advanced prototype or a product, so which you can actually demonstrate in field settings. So demonstration in field settings is the like final deliverable for the any technology development programs. So I think similar terms hold true for our technology mission programs also, where the focus areas are primarily water and energy. So under technology development programs, we have the thrust areas that we have identified that includes advanced manufacturing technologies, biomedical device technologies, then waste management program technologies, science and heritage research initiative. This is a new program which was launched in 2017. Here we are looking at the technologies which can be used in the conservation and preservation of our tangible heritage. So it could be our archaeological monuments or musical instruments, anything which has implications in our cultural heritage. Then we have device development program. So this and technology development program. So these two programs we have kept as generic platforms where whatever is not falling under our core thrust areas, and if we get some very good proposals, so they are included in these generic platforms. So they include all analytical instruments and agro technologies, textile technologies. So if it is deliverable is a device or instrument, it is taken to device development program. And if it is a process material, it is taken to technology development programs. So the main objectives are promotion of indigenous development and demonstration of technology. So ideally, our objective is up to demonstration of technology in field settings, but we do make proactive efforts to take that technology to the field and to the industry also. We consciously support technology awareness workshop, and if you want to have any kind of hand-holding and interaction with industries, so those activities we consciously support under technology development program as a part of our efforts to promote the commercialization of these developed technologies. And capacity building in terms of infrastructure and human resource, we do support some training programs under technology development programs for capacity building for human resource development also. And as far as capacity building in terms of infrastructure is concerned, under specific thrust areas, we have supported 1 or 2 hubs which have certain basic facilities for development of equipments, and plus they interact with industry and with academia. I will come to that model a little later. So at the technology development programs, we are playing between the field of around TRL 2 to TRL 5 to 7. So for TRL 5 to 7 is basically pilot demonstration, and in waste management technologies, we have taken a few projects for demonstration of technology. So otherwise, largely the output of our program, it goes between technology level 4 and 5. So that is the broadly the output of our program. But we are trying to go to higher TRL levels, and we are trying to reach up to 6 or 7, so that at least one valley of death can be crossed before the actually the technology is taken for the commercialization, or the investigators are seriously pursuing transfer of technology to the industry. So one interministerial initiative I have already spoken about with the Department of Heavy Industries. We are working on technology platform for electric mobility, and we are also working with Ministry of Railways, where Ministry of Education is also a party for technology mission for Indian Railways. Here we are looking at the technologies which are relevant to the Ministry of Railways. So DST, Ministry of Education, and Ministry of Railways. So we are equal parties to it. And we have developed an industry for platform for here we are working directly with the industry, and there is a rail coach factory in Raebareli. So we have developed an industry for platform for automation of shell shock factory. So, and this project was projected by Railways to the PMO, and it was very well appreciated. Now we are adopting the same platform, and we are just trying to adapt that platform for different applications with Ministry of MSME. So they have their technology centers, and they have such more than 300 technology centers. So we are trying to adapt this platform for very basic applications like carpet making, and to high-end applications like for automobile sector. So this is the importance or relevance of technology platforms. You can see one end it can have very high-end applications also, and the other end the same platform can be adapted and modified and used for the very grassroots level applications also. So these are there will be challenges definitely, like using it for an automotive sector and for a carpet making sector. These are two diverse applications towards the other end of the spectrum. But those challenges can be only met by the research inputs coming from our able researchers. And time and again, our researchers have established their excellence. Like if you look at the COVID era also, the capabilities which were there in the country, the capabilities and the infrastructure which has already been created. So it has been used wisely and very judiciously to combat the pandemic. And we have exhibited strong perseverance in that area, and we have come out in flying colors. So if we set our mind on something, we can definitely scale any kind of heights. So similar tempo, if we can maintain down the in post-COVID era also, so we can definitely, we will not be far in becoming the technology leaders, and our contributions will be recognized globally in all the fields. And as you can see in the Global Innovation Index also, now we have climbed up and we are in the first top 50 countries. So if we set the goal, and if we really take these programs, if we take these efforts seriously, we can reach in first 25 in no time. So coming to the major activities which are being supported under technology development programs. So I will be just talking about the mode of operandi, how we are implementing these technology development programs. So first of all is we have these call-based proposals for technology development and demonstration. So this year, in this current financial year, we have given 3 calls, one for the waste management, second for the biomedical devices, and the third one was under device development program, where the focus areas were agro technologies, drone-based technologies. So, and other were the generic platforms. So if I look at the response of these calls, so against the call for biomedical devices, we received around 238 proposals. For the other 2 programs, we have received 700 proposals each. So this kind of response against the call indicates, if I just make a gross total of all these projects, So we have received around 2,000 projects under technology development. So this is heartening news for the country. So the diaspora of these technology developers is growing year by year. But if we go out and see how many of these technology are transferred, are actually taken to the industry, so that number is still abysmal. So we really have to think of how to take these technologies forward. But ultimately, the promotional role of Department of Science and Technology has been very well served, and we have been able to elicit the interest of researchers to work for technology development problems. So the other activity that we are pursuing is we have established hub for development of biomedical devices. So two such hubs are operational in the country. One is at Anna University, Chandigarh, Anna University, Chennai, and the other one is at PGMIR, Chandigarh. So these hubs work on biomedical development of biomedical devices. Each have their specific area. So Anna University hub is basically looking at the engineering aspects and the commercialization connected to industries. And PGI hub at Chandigarh, they are looking at the clinical trials and all those related issues for biomedical devices. So next, we have created some centers of excellence under SHRI. So these two activities, hubs and centers of excellence, so they fall under infrastructure development. So so one has been created at CBRI Lucknow, CBIRI Roorkee. So there they are looking at the materials which have been used in the heritage structure and how to develop new materials for preservation, and non-destructive testing of those structures. So all those issues of building are being looked at that. And then we are also working on developing the consortium projects under waste management technologies. So here, Honorable Minister of Science and Technology has directed Department of Science and Technology to prepare a comprehensive roadmap for utilization of waste in the country. So for that, we have consulted 27 ministries. So they have partnered with us, and after this extensive stakeholder consultation, they have flagged some 12 problems, and our previous call was based on this stakeholder consultation only. So those problem statements now we have taken up, and we have called for the proposals, and we have received a hearty response. We have received around 700 proposals, and we are the investigators who are working on the similar areas and themes, they are grouped together so that collectively they come up with a solution to a composite solution for the problem. So this is how we are handling the consortium project. So mandatory industry partnership is there, and I'll be happy to share with you that over the years, this industrial partnership or industry contribution is growing by say around 5 to 7% every year. So grand challenges have been identified, and one of our grand challenges is open right now for development of biomedical devices. I'll come to it a little later. And then we are also working on a scheme to support from prototype to product, where we can partner with our our statutory body like KGB or with NEB, so that they can find the industry part and we can provide support for the institutional part where for commercialization of developed technology. So we can give some money to the institute for hand holding the industry, and the industry can draw the support from Technology Development Board. Similarly, startup can take the support from NEB division of DST, and from KGP, we can support the institute who are working with those startups for development of the product. So with our experience, when we interact with established industries, so when it comes to licensing the technology or transfer of technology, so during various workshops, so they have expressed they find it easier to deal with the startups than to do it with their respective institutes, because startups and the industries, they have similar language, so the exchange is relatively easy rather than taking a technology from institutes. So this, we are working on this scheme, and hopefully in the coming financial year, so this scheme will come out. So if you look at the statistics of KGP funding, so over a year, every year we are funding around, say, 100 projects on an average. So, and if you look at the gender distribution, technology development is one domain where we have like more projects which are funded to males, but the involvement of women in such projects, women faculty, is also picking up. And if you look at the zone-wise distribution of the projects, so most of the money from KGP, also like other schemes of DST, is going towards south. And if you look at the northern or central northern region of the country, most of the participation is either from Delhi or Chandigarh. So whatever funding is there, around 90% is going to Delhi and Chandigarh in the northern region. Otherwise, in technology development, the part of the remaining northern region is very negligible. So if you look at the data of projects which were initiated from 2017 and which have gone up to 21, so the total funding which has gone in supporting the project is around 225 crores. And by the end of this financial year, we will be adding 35 crores more to it. So it will be around 260 crores. So if you look at the average cost of the project which has been supported through KGP, it lies between 30 to 50,000. So this does not relate to the total funding figures, because there are few projects which are very high value project up to 20 crores, which have been funded through this KGP schemes. And so they don't account for the average project cost. So they don't figure out in this cost. So if we look at the average time to taken to complete a project, it lies somewhere between 2 to 3 years. And we have funded around 300 projects, and 193 are still ongoing. And 85 projects, prototypes have been demonstrated. So demonstrations, what I mean is ergonomic compact model or the technology has been demonstrated at the field site. And there are few projects where objectives were not realized due to mobility of the PI, the projects was abandoning between, or due to some other reasons, the work was not completed. So by and large, this percentage is still low in technology development programs. Most of our investigators who are coming for technology development programs, they are like committed towards their work. And in this process, we have trained through the projects only, around 800 manpower has been exposed to technology development. So we see as our human resource for future who will come into technology development activities. But otherwise, if you look at the statistics, so every year we receive around 2,000 proposals, and we are able to fund only say around 100 proposals. So what is the fate of these 1,900 proposals? Out of these 1,900 proposals, I can safely say 1,600 proposals, they do not have any scope of funding. They don't fall in the mandate or they don't fulfill the requirement of this scheme. So they don't fit in our window of technology development program. So the efforts that has gone in writing these 600 proposals, just because of not finding the right fit, goes down the drain. So it is very important whenever anybody is writing a proposal, you have to look for a right window to support your research. So those 1,600 proposals, we don't even need to evaluate them. Most of them are exploratory studies, and they don't fit in our window. And if you look at the remaining 400, 300 proposals. So those 300 proposals, they have the potential to come in the list of 100 if they can be justified properly, if they can be written in a better way. As far as the proof of concept or the novelty component is concerned. So these 300 projects are the projects which fail in evaluation, and they are in the borderline. So we also conduct workshop for such proposals so that what improvements can be done in those proposals, so to elevate their level for and make them more acceptable to the funding agencies. So look, if the mandate of biomedical device, I'll be talking about biomedical device and technology development program here on. So our mandate is to evolve and support projects for development of devices. So we have grouped the biomedical devices into three categories. One is early stage prototype development. Here you have integration, testing, and packaging of subcomponents in the laboratory. We call it a feasibility study. So by the end of this early stage prototype development, you show us a breadboard working model or open working model. Then we have late stage prototype development. Here you have to fabricate ergonomically designed compact prototype which can be taken to the field for limited testing and validations. Say if it is a biomedical device, it can go to at least 2-3 centers, 2-3 hospitals where it can be actually checked on patients and normal subjects. So this is our requirement from the late stage prototype development. Then we have pilot scale testing and validations. We do not support organized clinical trials, but we do provide some support for pilot scale testing and validation. Say if you have developed a biomedical device and you want to test 20 patients or you want to make 20 pieces and check at 2 centers. So that is the pilot scale testing and validation we support so that you can get the feedback from the clinicians as well as the patients to improve upon your working prototype. So in this, like once you have developed a late stage prototype and you want to go for pilot scale testing and validation, industry participation is mandatory. So here we are looking at the industry who is going to take up the manufacturing and mass production, not the industry who will help you in limited validation. So we have included screening, diagnostic, prosthetic, surgical, and life support equipments for clinical applications in healthcare sector under BGKG. So success stories, if you look at cochlear implant, I have already discussed. So the cochlear implant was developed with Gebel Bangalore under SBMT, and now it is undergoing clinical trials. So they have engaged an industry also, and that industry will be making 75 pieces of electrodes which will be used in the cochlear implant, and that industry has taken support from Technology Development Board. So this is how you can utilize different schemes of DSP to come up with the product development. And the second is the case of dialysis machine. So this is another case study where the project was initiated by Technology Development Program. So we did the fabrication of dialysis machine through institutional support, and Renalix was the industry partner. Eventually, they took certain components from this dialysis machine, which includes bubble detector, electronics module, and there was one another module. They took it from the one which was developed through KDP support, and then they took support from Technology Development Board, and right now they are into manufacturing of dialysis machine. So these are two classical examples where the project has been initiated by Technology Development Program, taken up by the industry, and industry got support from Technology Development Board of TST. So right now we are working on dialysis cartridge also, and for the dialysis cartridge, we have reached a stage where we are doing the animal trials, and hopefully we are targeting in another 1 year, we can come up with a veterinary dialysis cartridge. So when we receive a proposal in under these technology development programs, so whatever I am discussing for biomedical devices holds true for other components of technology development programs also. So first we look at the proof of concept, the work which has already done by PI. So for us to assess the competence of PI, so more than publication, the proof of concept, the work which shows that the idea is workable is more important. So definitely we will look at the publications to assess the competence of PI, whether like PI has some experience in that area or not. And when we look at proof of concept, we look at the inputs of clinicians also. Okay, how closely the investigator has worked with clinicians to arrive at this particular idea. So in biomedical device and technology development program, involvement of clinician as a co-PI is mandatory. Then the next is clinical need. That need has to be established. If the clinical need is not properly justified, straight away the proposal will be rejected. Then novelty. What is the novelty component? What new dimensions you are adding? If it is an existing prototype and you are doing some kind of reverse engineering, so what kind of new dimension you are adding to the existing equipment, or what is the novelty of the method that you are using to solve an existing clinical problem? Then deliverable. What kind of deliverable you are offering to us? If you are offering us a project completion report, then it's a straight no. So what will be your deliverable at the end of your journey once you complete the project? So at least you need to give us a prototype which can be taken to for clinical validation. It may not be a compact prototype which can be directly taken to the market, but it should be compact enough and give the data if actually tried on patients. So that is our deliverable. And then areas like antibody-based diagnostic kits, bioengineering products, all these things are like beyond the scope of biomedical device and technology development programs, because most of these areas are covered by Department of Biotechnology. So far we have given 2 specific calls of proposals under Biomedical Device and Technology Development Program. As you will see that as we have progressed from one call to the another, we have become very specific. So we are defining our requirements in a specific manner, adopting a top-down approach, so that whosoever, so in the first call, which was launched in 2018-19, it was a generic call. So we have included non-invasive devices, preventive healthcare mass screening devices. Here we have not identified the specific areas. But when we gave the next call, so when we are talking of women diseases, we are defining all the diseases. So we are becoming more specific. We have done massive stakeholder consultations to arrive at these calls. So this call was closed on 31st October, and we have received 236 proposals, and we will be funding 48 proposals under this call. 30 have already been funded, and 18 are under various stages of processing. So this is a radical shift which you will observe in DST everywhere. So the calls are becoming more specific, and they are clearly defined to what exactly is desired from the investigator. And you have to fit yourself within these calls. And if you don't find your place in these calls, then your proposal will be summarily rejected. So whenever you are addressing you are trying to submit a proposal against any call, please go through it carefully and just confine yourself to one of the areas which you are interested in. Now there are no broad areas. The requirements are very specific, and please read it carefully, and then you align yourself according to the requirements. So currently, the grant challenge from Biomedical Devices and Technology Development Program is open. So what we are looking at is we are looking at totally indigenous point of care device. It could be paper-based device, or it could be lateral flow device, or it could be a microfluidic device. So which should be economical, and whatever solution you are proposing, it should be scalable. So it's a point of care devices for quick detection of anemia, nutritional status, including vitamin deficiencies like A, C, D, K, B complex, all in one single go. So you have one device, and you put a drop of blood or drop of syrup, and then you can just look at all these vitamins in one single platform. So because individually, if you take these vitamin deficiency tests like ACD, it turns out to be very expensive. And in biological systems, we all understand you need not be specific to the 4th place of decimal. So if we can have a device which can say, find the person is deficient, or it is is highly deficient or moderately deficient also, so that will also serve our purpose, especially for this kind of deficiencies in pregnant women are very important to be traced. So we are looking at a cheap solution where in one go you can provide the solution, or you can provide the status of all these vitamin deficiencies. We can have different panels for say vitamins and mineral. So we can have two different devices for these two. So depending upon the chemistries, so whatever you can couple, but at least for vitamin we would like to have one panel, and for mineral we can have another panel. So, so chemistry has to be designed if you are using a chemical method or electrochemical method, whatever method you will be employing. So the chemistry for each of these, or the method, has to be integrated in such a manner so that in one go we have readings for all the vitamins or the mineral, all the efficiencies. And the device should be compatible with high throughput and surveillance needs, because so that it can be used as a screening device. So here the problem is very well defined. So what are the desirables? What exactly we are looking for? And industry participation is mandatory for this challenge. So, and the consortium approach will be preferred. Like you have this multi-institutional team working together, multi-departmental. So if you have a consortium, so budget allocation will be made for every member of the group. And so all the members have to contribute, and their contribution has to be defined towards solving the problem. And so since this was a grand challenge, and people have investigators, they really have to work on identifying the right teams and then working together to come out with a proposal. So this was kept open for 6 months, and this will be closing on 31st March 2021. There will be no extension for this call. So there is no, I mean, so far we have not put any cap on budget for this challenge call. So once we open the proposals, then only we can comment on the cap of budget. So the other venture we are supporting through this program is creation of hubs for biomedical devices. So far we have created 2 hubs. So we have in this we have hub administration, and one component is given for calibration of medical equipment. So this calibration facility in Anna University, we are in the second phase of hub. First phase was given for 5 years, and now the second phase is ongoing. They have already crossed 2 years. So the support will be given for another 3 years, and after that, DST will stop supporting it. So their calibration facility has become self-sustainable. They have generated the business models, and they are providing services to the nearby medical hospitals, and they are generating revenue out of it. And this facility is completely self-sustainable now. And then we have one component of productization and commercialization. So if there are some investigators who have worked up to technology readiness level 3 or 4. So hub links them with the industry, and then try to convert that prototype into product with the help of industry, and aids in commercialization. Through this activity also hub generates some revenue. So this is another activity which is done by hub. And the third is maintaining a regular interface with industry and clinicians, so that they can generate new ideas and new problems and circulate it to the people to work upon. So they are also doing the market-oriented societal need-based exhibitions of the products or prototypes which have already been developed by the KSK supported projects and through their own support. And they are also providing the infrastructure and support for IPR, filing patents, and product realization and commercialization through their existing facilities. Like IIT has a Sati facility, so IIT can very well utilize that facility for supporting this kind of ventures. Then they do workshop, conference, training, certification, and designing activities on the regular basis for the benefit of the technology developers. So how to go for C certification, or how to get the CDCSO clearance. All those workshops and training programs are conducted by hubs on regular basis. And hub is also implementing a cluster of projects, say 8 to 10 projects which have been identified by them, and with a full plan starting from prototype development to commercialization. So if you look at now one by one, I'll take you through the other components of technology development programs. The basic conditions remain same, which I have discussed it for medical devices. The only difference is in medical devices, the involvement of clinicians is essential. And while for the other programs, we encourage participation of relevant stakeholders. So if you look at the waste management, the broad objective is to promote development of suitable technologies with the potential to ameliorate environmental load from a huge amount of residual generated by industrial development and consumption lifestyle. Under advanced manufacturing technologies, we are promoting robotics, automation, precision manufacturing, additive manufacturing, biomanufacturing, 3D printing, etc. So then technology development program these are generic platforms. So here we are looking at the application of modern and advanced technology for socio-economic problem solving, then modernization of traditional tools, new applications of certain established technologies, developing the technology platforms. So this is a generic platform. And Science and Heritage Initiative, I have already told about. Okay, we are looking at study of heritage materials, then remote sensing techniques for detection of archaeological residues. So these are all like scientific applications, application of science and technologies to address the cultural heritage related issues. So it could be non-invasive manufacturing, or it could be process development or coating development for heritage material to conserve them. So all these are covered under SHRI. So then we have a generic platform, then device development program. So here we are looking at indigenous development of devices, which are not covered in our specific areas. So if you look at the output of any technology development program, so input is the time and money you have invested, and the output is how do you demonstrate the technology. So this is a project for development of clubfoot brace, which was sanctioned to CMC Vellore and IISc Bangalore. So IISc Bangalore was a technical partner, and CMC Vellore was a clinical partner. So they have developed this brace. So our primary output is technology demonstration. So then so they have given, done the trial of this place on around 1,000 children at 10 different centers in the country. And so the byproduct, the added value of this project outcome is they are working on few more devices. Once this group, this alliance was formed, now CMC Vellore, after this project, CMC Vellore and IISc Bangalore, together they have done more than 10 projects and to solve different problems related to this orthopedic deformities, and one on gynae problem also they have worked upon. So similarly, like once this alliances, the relation is established between two institutes, so it has given rise to 10 more similar projects. So once you submit a technology development project or towards the progression of the project or the end of the project, so these are the parameters on which your progress is evaluated. So patent status, validation testing, whether you are doing it or not. So these are the parameters from starting the day you submit the project and towards the progression of the projects. All these parameters will be looked into, how you are progressing on these parameters. So this will be the evaluation of your project potential during the course of project. So future work, like, so once you complete the project, what kind of work you envisage, industry alliances that you establish during the course of project or in the beginning of projects, and opportunities, what are the opportunities for potential takers, and what kind of candidate support is required, and how do you plan to arrange that kind of support. So the R&D indicators that we are expecting, the main is technology demonstrated and offspins from developed technologies. We have seen in some of the technology development programs, the intended use or the Incangig application that was not achieved. Rather than many offspins came from the technology, which has more value than the technology itself. One such project is under waste management. So we have supported this project for utilization of thermocol. So that work was done at IIT Hyderabad, and that patent has been evaluated at 58 crores. And we have invested 34 lakhs in that project. So this is the kind of, and the project was initiated so that this thermocol sheets, they can be dissolved in linoleic acid, and that fabric thus created, it can be used to absorb the oil spills from the ocean. So intended objective was not achieved, but they were able to create a towel which can be used in the kitchen applications and all other applications where you want to wipe off the oil. Thus, we are solving a problem of this waste also, and at the same time, you are generating a product which has a market value. So this is the potential of the technology. So what these technological development programs are intended at, how this Indian R&D institutes, Indian institutes of excellence, or our institutes of higher education, so how do they contribute in making our India Atmanirbhar? Because these are the technology centers. They have human capital. They have all the resources. They have the ignited mind to, and if we bring these ingredients together, so definitely we can really contribute towards Make in India, and whatever is happening in the lab, it can actually be taken to the land. So like if you have any such ideas, and if you want to work on any spectrum of problems solving approach, you please refer to our website of DST and SCRB websites. Even SCRB has also scheme to support technology development. So technology development initially, like it's if we look at the history of DST, it was started from a point where like project reports were given at the end of the game, or some technology transfer documents were generated. Okay, fine, the technology has been developed. When I look at the investment, if I look at the investment in technology development programs from a period of 2006 to 2017, so we have supported projects worth 70 crores, and the number was 200. And if I look at the development during last 3 years from 17 to 21, so we have supported around we will be, by the end of this year, we will be supporting around 350 projects, and the investment will be 400 crores. So this is the amount of support which has increased over the year, which itself shows the importance of technology development programs. And as far as the spectrum of deliverables is concerned, initially we were talking about project completion reports, and now we can see the robust demonstration of technology happening in the industrial side. Just to show you, so these are the outputs of our hubs which are working in the area of biomedical devices. You can see how beautifully they have like packed these devices, and they can be easily, conveniently tried on the patients. So this is what we are looking at towards the end of the project. So now these are few products which have been developed through, I'm just scrolling through it. So see the professional look the products have got. So this has been transferred to industry, and now the industry is manufacturing it. So again, this all these technologies. So this is another one model which CPEC has adopted. So they have established this electronic waste facility where they are segregating the plastic and electronic waste processing facility. They have put up a pilot plant in their premises, and they are leasing out that pilot plant to the industries. So industry is taking that plant on lease for a year, so that they can try their hands on the technology which is available. And if they are satisfied, they can set up their own plant. So this is another very good model which came to our notice. So these are again and so this is where I wanted to emphasize. So PIs are demonstrating their technology in actual industry settings. So they have come out of the lab and they are working in industrial settings. Here we are talking of like pilot scale synthesis or pilot scale manufacturing. So this is where the technology development programs have evolved from the paper report to working in actual field settings. So here you can see a rudimentary prototype. This is for, I think, Raman spectra developed by CSR, GST Institute. And then we are talking of pilot scale. And then we are talking of putting up a plant in actually industrial settings. So this is the potential of technology development programs. And this is the kind of growth which we have seen over the years in DST supported projects. So these are a few other prototypes just to encourage the viewers what kind of products, the shape they have taken. This is from IIT Delhi itself. So this is the scientific team in DST, which is working towards technology development program. I acknowledge the support rendered by Head of our Division, Dr. Anita Sharma, and the support of my teams, young colleagues who are working around the clock to implement these programs. So with that, I will close my session, and I would like to give you an example of xenobots. So this is the ultimate realm of technology that we have reached, where we have mixed the living and non-living component together, and we have made a hybrid which can survive. So this is the potential of technology, which can even integrate the living and non-living forms and come up with something new. So India has already ranked world third largest publisher of science and engineering articles, and we have reached a position of 48 in Global Innovation Index. So we should put our best foot forward and see to it that whatever happens in R&D should not stay in R&D and come out of it. For that, DST is always there to support you in your endeavors. With that, I extend my thanks to all the listeners and viewers who have attended my presentation with the utmost patience. Thank you. And thank you, Dr. Khare and Professor Dr. Mukhopadhyay, for giving me an opportunity to interact with the IIT faculty members. So if you have any questions,
Thank you so much. Thank you so much, Dr. Anita. Thank you so much, Dr. Anita Aggarwal. Actually, it was even eye-opener for me. Typically, we understand R&D projects from DST. Though we are aware of the TDP programs, but not much in length actually. And you are telling us the grant challenges, especially the one which is still open actually up to 31st March in the devices. And you're taking us forward toward programs and especially telling us where do we fail basically. Also, the eye-opener was kind of statistics you provided that 100 are selected and rest of it, out of that 100 are rejected because they don't reach to the level of this. Another thing which I learned was that you also organize workshop to make the aware how to actually prepare for such things. And I appreciate and congratulate you both actually in terms of the objective for the nation, wherein we do R&D in the labs, but translating it to in the form of the national scheme, industrial transformations, it's eye-opening. The Xeno robot which you showed, it was really, I was mesmerized to see that thing. So thank you so much for so passionately telling us about each thing, and for us and our faculty members. We are really grateful to you, ma'am. And you may be already interacting with our colleagues, Dr. Mukhopadhyay, my Associate Dean, Professor Sukumar Mishra, and both R&D coordinator, Dr. Archana and Dr. Harsita, I see there. So we were actually very keen to listen to you, and I must tell you that it was rightly so. I think so. Thank you so much.